Hello students. In the present session, we'll discuss about the different culture systems used for secondary metabolite production. In the previous session, I discussed about as to what are secondary metabolites and the methods utilized to increase the production in vitro. This figure summarizes the different approaches used to increase the production of secondary metabolites, followed by upscaling of production of secondary metabolites after optimization in vitro. In the coming slides, I'll discuss about the different culture systems used to produce secondary metabolites. After optimization of in vitro cultures for production of secondary metabolites using both biotic and abiotic regulators, the secondary metabolite cultures are then synthesized in different culture systems. The commonly used culture systems are free suspension cultures, immobilized cell cultures, two-phase system cultures, and hairy root cultures. Free suspension culture techniques I have discussed in my earlier sessions. Next, immobilized cell culture technique for secondary metabolite synthesis. In this technique, the cells are confined to defined region in a space while retaining their catalytic activity, and it prevents its entry into the mobile phase which carries the substrate and the product. Immobilization of plant cells, protoplasts, or embryos are achieved by binding these materials onto or within a solid support or matrix. Based on the type of matrix or nature of matrix used, they are grouped into three major categories. Natural polymers, which includes alginate, chitin, starch, collagen. Synthetic polymers, which includes PEG, DEAE cellulose. Inorganic materials like silica, glass, charcoal, activated carbon. These matrix are inert materials. Cell immobilization on the matrix or support can be by means of adsorption, cross-linking, covalent bonding, entrapment, or encapsulation. These immobilized cells can be used in different types of bioreactors for scale-up. The different types of bioreactors used can be mechanical stirring, airlift, bubbling, nutrient mist, etc. Mechanical stirring bioreactor is not widely used because some cells and tissues could be sensitive to the shear force. In the bioreactor, various sensors are used to monitor the pH change, temperature, dissolved oxygen, etc. for maximum and optimized production of secondary metabolites. Two-phase culture systems for secondary metabolite synthesis. Here, the first stage or phase in vitro favors cell growth. The nutrient media and conditions are optimized for cell division and growth to increase the biomass. Once the biomass is reached, the second phase starts. In this phase, the nutrient composition and other parameters are modified which supports secondary metabolite production and accumulation and also reduces feedback inhibition. The industrial large-scale production of chiconin utilizes a two-phase or two-stage culture system. In the first stage, cells of a high-producing strain M18 are allowed to proliferate in growth medium Mg5 without producing chiconin derivatives. In the second stage, these cells were transferred to a media for chiconin production. In this type of system, the production increased approximately 12-fold. Secondary metabolite production by means of hairy root cultures. Hairy root cultures are differentiated cultures of transformed roots generated by infection of wounded higher plants with agrobacterium, rhizogens. Hairy root cultures produce the same bioactive chemicals corresponding to the intact parent plant and roots. Higher stability and productivity of hairy root cultures allows the exploitation of hairy root cultures as a valuable biotechnological tool for production of secondary metabolites. Steps to induce hairy root culture. Hairy roots are produced by infecting the sterile plants with Agrobacterium rhizogen. The explant could be a leaf, hypocotyl, petiole, tuber, etc. Generally, Agrobacterium strain Agropine is used for effective infection. In some plant species, infection is achieved by addition of acetosyringeon. After infection, to eliminate the redundant bacteria, antibiotics are used. The infection causes neoplastic growth of roots that are characterized by high growth rate in hormone-free media and genetic stability. Confirmation tests for hairy root cultures are done by means of morphological characters, biochemical and genetic markers. After the induction of hairy root cultures, they are maintained by subculturing. The cultures are then manipulated for enhanced production of secondary metabolites by the use of elicitors, media optimization, precursor feeding, metabolic engineering, polyploidy alterations, etc. The hairy root cultures can be utilized in bioreactors for scaling up or large-scale industrial production of secondary metabolites. It can be used in stirred tank bioreactors, airlift bioreactors, bubble column bioreactors, turbine blade, mist bioreactors, rotating drum bioreactors, and spin filter bioreactors. The figure here shows hairy root bioreactors. The figure here represents the process of induction of hairy roots in the target plant for secondary metabolite synthesis under in vitro conditions and also scaling up of hairy root cultures in bioreactor stage. Various types of bioreactors can be used for hairy root cultures. This is then followed by isolation and purification of the secondary metabolite by downstream processing, followed by packaging. The advantages of hairy root cultures with respect to intact cell cultures are that These are genetically stable with high growth rates and increased metabolite production. In certain cases, the hairy root cultures produce more secondary metabolite than the differentiated cell lines. The hairy root cultures can be manipulated to create transgenic lines. Hairy root cultures also has the ability to generate into whole plantlets if triggered with external stimuli. This is a list of certain bioactive secondary metabolites developed by hairy root cultures. These are certain pharmaceutical products of interest that have been produced successfully by tissue culture. Example, Taxol, which is a promising anti-cancer agent. Morphine, L-DOPA, which is actually used as a potent drug for Parkinson's disease. Diastenin, a phytosterol used in synthesis of steroidal drugs. Capsaicin, which is used as a pungent food additive in formulated foods and also as a digestive stimulant and for rheumatic disorders. Here, advantages of secondary metabolite synthesis by plant tissue cultures are enlisted. The figures here show production of secondary metabolites from tobacco and lithospermum. Thank you.